My name is Adam Brososky. I am an electrical engineer by trade. I've worked for defense contractors for the past 10 plus years. In my time there, I also was a firefighter. I became a firefighter in 2009 when I was just finishing my master's degree from Purdue. I decided I wanted to give back to the community and help out that way. So I went down to our department and they instructed me that I needed to sign up for the training classes. So I went through a year-long training program and got my Indiana State certification in firefighter 1 and 2 and hazmat awareness and operations, and became a firefighter on the Huntertown Fire Department. I was there for about 3 years. I not only did firefighter work, but I also did a lot of technical work around the shop as well. So we developed our systems, the tracking systems for the military. There were some very harsh environmentals that we needed to take into account, especially during launch of UAVs and recovery of UAVs. There's some environmental issues and concerns we had to take care of. We found that when designing the Eliminator system that we also had to take all of these considerations into account, because they're going to go into a very rough environment of a fire truck, ambulance, police car, or a traffic cabinet for that matter. We developed tracking systems that had to be down to less than 10 feet-ish of precision. I mean, the GPS was just part of the solution. We use GPS and video along with radio direction finding to keep track of the UAV. We developed the preemption system with higher power and longer range. We're over 2.5 miles where we have radio communications between 2 points. We developed this to overcome issues that other preemption systems have with difficult situations they have to deal with. The first difficult situation is a traffic signal that typically has a lot of traffic at it. We want to be able to tune our system to preempt that light in an adequate amount of time that clears the traffic out for you. The engineers and technicians who set this up are given the flexibility to provide longer times before preemption happens at the traffic signal. This is primarily to allow in those tough situations for the traffic to all be clear, so you get there and it's already an open intersection for you to go through. It's not surprising at all to hear reports of other stations not even having to hit their brake pedals when approaching traffic signals and going down a main drag in a town. A system that could only has 2,500 feet of range versus a system like the Eliminator that has 2.5 plus miles of range. The shorter system could preempt the light at a time where you don't want that light to be preempted. It's a time that will cause more issues than good. Whereas with the Eliminator system, you can clear that traffic light out before you get there and before anybody else is there. We designed the system to take a more proactive approach to preemption by allowing our installers and our engineers, when they set up the system, to tune those difficult traffic intersections where other systems just don't have the power and the range to do that, especially in very urban environments where there's lots of multi-path communications and you have a lot of noise. Our radios really help punch through that noise with the extra power that we have. We also have a mesh net of radios that all of your traffic signals across that are all talk together. So even if you don't have direct contact to that far point, we can still talk to that point through our mesh of radios, which gives your system the flexibility to be set up in a way that provides you with the fastest path through difficult situations in a town or city. That was really the driver for using these higher power radios with this MeshNet technology. MeshNet is a very powerful tool for what we're doing. One of the features we built into the system is a soft button into the console that allows for preemption of a nearby traffic signal while you're at the station. This software feature allows for no additional software, no additional buttons, no additional hardware. It's part of our standard software build. The patented collision avoidance that's built into our systems is designed to work vehicle to vehicle. So we don't have to be connected through a central point like the traffic signal. We actually have communications that go directly from one vehicle to the other vehicle, and using our algorithms built into the software will detect and alert the user of an impending collision with another emergency service vehicle. The Eliminator's communication system is designed to be Zigbee compatible, which allows us to be compatible with the new smart city systems. We also have options to enable cellular communications as well as Wi-Fi and different networking capabilities. So there's a few disadvantages to using a cellular-based preemption system. The first being cost. Every message you send costs money. The second major issue is the fact that there's a delay induced by your cellular packet, your cellular data is going to have to be sent to a server. The server is going to process it and then send a message back to the rest of the system. Whereas using a direct 900 megahertz system, you are point to point passing that data directly to where you want it to go. There's no redirection, which helps eliminate issues with latency and timing. The third is the fact that you're passing data that could well be sensitive over a public pipe. This public channel, even though it is encrypted, it can be intercepted and can be either overcome or jammed, for that matter. And the fourth major issue is that we see time and time again during major natural disasters that our cellular networks become overcongested and they shut down. And having a direct link from point to point where you want to talk to, where you need these critical communications, you're not relying on anybody else's network but your own, which helps mitigate that possible issue. One of the advantages of having the point-to-point network that we operate on is the fact that we have an encrypted channel that is private to us. We're not using a network that's being congested by anybody else. 900 megahertz is on the ISM band, which other people do use. But our channel that we are operating on is an encrypted link from one point to another point and is set up during the initial system deployment.